intention is to give you a small presentation, two presentations actually. The first one is basically a survey of graphing parabolas on a graphing calculator. So the intent is to teach you how to use a graphing calculator to take a function, and in this particular case we are using a parabola, and we're going to be using the vertex form of the parabola. So my hope is that you will know and understand how to graph, at least on paper, using a table, certain functions, but I'm also wanting you to learn how to take advantage of functionality on your calculator to do that. So that's this form right here. Okay, so we're starting with this one right here. So we start off with we're using TI-84 calculators, and so you want to look at the top and see that it's a TI-84. I also have this one's called the TI-84 Silver Edition Plus, and so either one of those works just fine. Now, one thing that I want you to be aware of is that sometimes we can punch in something into your calculator and everybody else gets something and you don't get anything except an error message, right? And part of the reason why is because sometimes these calculators can get set into a parameter that makes a range or a domain not permissible, and so you end up getting an error code. And so if you get an error code, we may have to do a reset on the calculator, and sometimes a reset will delete programs and things that you may have previously entered into your calculator. And so if you have programs in there, we might lose some of those things in order to gain some of the learning from this class. We start off with, is that okay? I want to start off with talking about the general form for a quadratic function in vertex form. And actually what I'm going to do is to talk about the fact that the basic function, what I refer to as the parent function for this discussion, the parent function looks like this. Now hopefully if you've been in algebra or even geometry, that you know that this function looks like this, right? It just has this appearance right here. And this shape right here is called a parabola. So when I mention what I refer to as the parent function, this is the parent function. Okay, this picture right here. And so when that's the general form. When we're actually going into talking about a parabola in what's called vertex form, and we consider the fact that not only is it in vertex form, the reason why we have to call it vertex form is that we've translated it and we've actually made some modifications to the parabola. So if that's the case, then now we have a function that looks more like this. Y equals ax minus h squared plus k. Now let me remind you, before we even go any further, that this right here, this point right here, is called vertex. And vertex form finds a new position for that point called vertex. In a parabola, vertex is either going to be the minimum point of the parabola in the function, or it's going to be the maximum point. In this case right here, it's minimum. So I'm just going to write min. And the reason why it's called min is because as we're looking at the parabola, all the points on the parabola are heading off to positive infinity from the left and from the right. The lowest point of the parabola is this point right here called the vertex, and that's the minimum point, okay? If I was to change the parabola in some way so that it draws like this, let me change the color of that. Then my vertex then moves to the top. And as we're looking at the parabola, it's heading down to negative infinity on both sides, on the left and on the right. It's going to be heading down to negative infinity. And so the topmost point, that red point that I just showed you at the top here, is now the vertex, and the vertex in this case is the maximum point. Right, so we have minimum being the lowest point, maximum being the highest point. So when we're talking about the vertex, we're talking about either the minimum or the maximum. Now, one thing that I wanted to mention to you, and you probably already know this, is that TI-84 and the TI-84 Plus graphing calculators are rich in functionality, and they can help you solve a lot of mathematics problems. And today we're only going to be focusing on one capability, and it's actually a capability that isn't often used by a lot of students. And so while we're entering these functions, you may consider the many ways that the parabola can be graphed. So the goal today is to look at different parabolas, and not only look at different parabolas, but look at them and using the benefits of the graphing calculator. So here are a few things to consider. Here are a few questions. You see the bullet points that we see here? That's what I want you to be thinking about. These are the thoughts that I want you to have as we go through this. I put 7 problems on this sheet of paper. And the first problem is just simply learning how to use the graphing calculator to graph the parent function. But here are a few things as we do 2 through 7, questions 2 through 7. And here are the questions that I want you to consider. What is the shape of the parent equation? What is the new graph? Is the new graph that we're going to be coming up with wider or narrower than the parent equation? Does the new graph open up? Is the new graph opening down? Has the graph appeared to move from left to right? Has the graph appeared to move, and I'm sorry, I didn't mean to say left or right on the second one, but to right up or down. So is it up or down? And then where are the x-intercepts is another thing that I want you to pay attention to, and or are there no x-intercepts at all? And so those are some things that I want you to be considering. We start with, let's actually take a look at the face of the calculator here. You see this button right up here? That's called the y equals button, okay? And if you press that button, let's actually all turn on our calculators and press that button. Now somebody came in here and said that they didn't have a calculator. You? You can borrow that one, okay? But don't walk out the door with it. It needs to come back to me. All right, if we press that button, and maybe previous people have used it, and you have other functions that are already put in there. You have a column of y1, y2, y3. Do you see it? Okay, that is called the y equals editor. Okay, and what those are is y1, y2 are different functions that we can enter into the calculator. And it's the bigger brother. Up to a point, I would say that you want to use it. 84, I think 84 is really the most popular, and it's really a good calculator to use. If you're going to be getting into calculus, then you want to use an 89, because if you're going to be having a student that wants to get into being an engineer or studying some line of work that line of vocation that requires higher maths, then TI 89 might be the way to go. Okay, that's what you have there. Is that what you have?
Is this compatible with the 89?
It is not. It is not. The 89 is a much more powerful calculator, and all the keystrokes are not necessarily the same. So the key sequences for what I'm talking about here are, work on a TI-84. Okay, for a TI-89, you might have to swim through a little bit and try to find the equivalent key sequences on your calculator. Okay, so your screen should have a column of y1s and equal signs after them, right? This is the y equals screen. The next thing I want you to do is you'll see a key, actually this key right here, that's your variable key. So sometimes the variable is going to be x, sometimes the variable is going to be t, sometimes the variable will be theta, and sometimes the variable will be n. Many times when we're in function form, when you hit that key, you will get an x. Okay, so go ahead and hit that key, and you get an x, right, right next to y1. And then the next key I want you to hit is what I refer to as the hat key. I also call it the to the key because it's the words that we use when we're creating an exponential for a power, right? And we say x to the, and then so hit that one, and you get a little hat or a little box that's going on there. Are you stuck?
You can't do two graphs at once.
Yes, you can.
I put in two graphs and I didn't work.
Okay, well we'll have to address that after the class, okay? So what I want you to accomplish is getting something effectively that looks like this function right here. So when you hit the to the button, hit a 2 and put it in there and then hit enter. So you should have something that looks like this. In that graph, right? Okay. I'm going to ask you to just go ahead and hit graph. So there's a key right here called graph. Go ahead and hit graph. And there may be a variety of different results, amongst you all here. And the reason why is because your window may be looking at the wrong thing. Okay, because your window could be looking at, a graph that's only right here. And if you're looking at that, and your window only looks like this, then you're only getting a part of the graph that I'm intending you to see, right? So you want your graph to be maybe more with a window that looks like that. And so we're going to be talking about window settings. If you flip the page, what I really want you to do is to take a look at where it says window. Now to get to window, you can hit the key that's called window. So go ahead and hit the window key. If you can't find it, it's located right here. You can use a brighter pen for that. It's right there. So go ahead and hit the window key. And if you hit the window key, then you should hit -5. Now, not -5, negative. There's two keys, right? One's called negative, which is in parentheses down at the bottom, and then there's minus. We don't want to hit minus. Hit the negative key, and then hit 5, and then arrow down and turn x max into 5. X scale is 1, y min -3. I always like to put a little bit below just to give just so that it will draw the x-axis. And then y max, let's make that 30. And then y scale, leave that at 1. Now hit graph. Yes?
So we have you say that the name is invalid.
Okay. For you, whose calculator is that? Is that yours?
Yeah.
Okay. Are we okay with resetting it?
Yeah.
Okay.
It's like error response.
So go ahead and
It
hit.
could be in a different.
So hit second and mem.
Oh yes.
And then go down to 7, which says reset.
Here, tell you what, let's just trade.
Thank you.
Okay. And then you can clear reset the calculator, and it should be able to do that. So right now, yeah, if you hit graph, you should have a picture that looks like this. Does everybody have it that way? Were you able to get your TI-89 to work that way?
I don't know where the variables are.
Okay, then we're gonna have to work later on that because you don't have a TI-84. All right? This class is only focusing on TI-84s for today. Maybe the TI-83 is working fine, right? Okay. So there that is. So what I'd like for you to do right now is let's actually go through this and everybody get, oh no, I have a problem here. These aren't showing up. Okay, we're gonna have to do this one on the fly. Let's see if you can graph these things. The number 2, 3, 4, 5, 6, and 7 was supposed to actually have content in them. I'm not sure what happened, where those went to. But number 2 was supposed to have something like this. So see if you can punch that in. And then hit graph. Now, have you done it? Okay. Can someone raise their hand and ask and tell me what they see that's different from the parent function and this function that we see? What were you raising your hand?
I guess the slope is
Right, so it's going to be a steeper and a narrower parabola, right? So if our parabola originally looked like this, now with the 2 in front, it looks a little taller, right? Let's try another one. Now we're going to do this. And we're going to make a couple of changes here. I want you to do this. Try putting that into the y equals.
I think I need.
It's actually off.
Wait, how do you get out the exponent? How do you get out the exponent?
Hit the right key. Hit the right arrow key.
Oh,
Okay. Did it do it?
yeah.
Okay, so somebody raise their hand and tell me what difference do you see on this graph from the parent equation?
It isn't hitting the x-intercept.
So the vertex isn't at the origin.
Right, the vertex is not at the origin. Where is the vertex?
It's it's at the
First quadrant.
Yeah.
Okay, so very good. So basically what we're saying is that the vertex, notice, is located at 2, 3. Okay, there's our h and there's our k, right? So we call this the vertex form because we're actually moving the vertex to a new vertex position, and we're calling it h, k. And if you look at how that's actually written, we have x minus h plus 3. That's what I was talking about here earlier as we were talking about vertex form, because the vertex becomes h, k. And so we saw it move on this particular graph. We saw it move 2 to the right, and we saw it move up 3, right? And also, what did that half do to it? What? It made it wider. It made it wider. Okay? All right, here's another one. Oops. Now, if we didn't change our window, you probably would get a graph that looks like this. There's no graph in there at all, right? So we're gonna have to change our graph a little bit. So let's try this. First of all, just by looking at our new h and k, do we see that we have an h of -2 and -4? So that's where our graph is going to begin, and I'm going to want to have that at the top of my window. And by the way, what's that -3 going to do? Anybody know? What's it going to do to our parabola? It'll turn the parabola upside down, and it'll make our vertex the maximum point. Very good. Okay. So if that's the case, then our expectation should be that we're over here somewhere, like that, and my vertex is going to be right there. So let's come up with a reasonable window, shall we? How about a top of -4 and a bottom of maybe -20? So that'll change my y mins. My y min is going to be -20, and my y max will be -4. Let's actually just make it -3. Give it a little bit of room at the top. And then from left to right, let's have x min be -10 and x max be maybe 5. And now if we graph it, there, I captured it and stuck it right in the middle of that window. Did you get what I was doing? I'll read my window to you again, okay? X min, -10. X max, 5. Y min, -20. Y max, -3. And then hit graph. Did that work okay? Did it work? You tuned in the middle? Yeah?
Oh, yeah.
You did? Okay, good. So what's the difference? What are the differences that we see? How is this different from the parent function? Someone give me a full description of what happened, Matt?
Since there's a negative number in front, it flips the parabola upside down.
It's flipped upside down. And what else?
And it's moved to the left.
To the left, and
Skinnier.
it's skinnier, and
It's not touching that.
right, so it